Excuse me. So this is D4, and we're shooting a paintball at 64 degrees at a 13.5 meters per second initial velocity, and it's going to travel in a nice parabolic trajectory and go into the wall over there, which is 3.8 meters over. We want to know how high up the wall it splattered and what angle and velocity it impacted. So first thing we want to find out is the dV. How can I find out the dV? We have an equation for that. And that's going to say gt squared over 2 plus dvit. The problem is the only thing I know there is g. So I know that already. Oh, I know the 2 also. And I know that that's going to be squared. And I don't know anything else. So do I cry?
No. Yes.
Well, some of you do, but
Crying is good for the soul.
okay. So what we're going to do is we're going to take this and we're going to break it into a triangle. Over here, of course, we're going to use sine of 64 times 13.5, and over here we're going to use cosine of 64 times 13.5, because that's the way we break these things up. The calculator, of course, has to be in
Degrees.
and that gives me 5.9. Okay, so we have broken these up, and of course this one is going to be my VH, and this one is going to be my VVI. So I'm saying, hey, I was missing a VVI right here, so now I can stick in the 12.13. So I got that going for me.
Yes.
But now I'm missing a time. How do I find the time?
DH is equal to VH times T.
Oh my goodness. So I
Good job,
say,
Mohammed.
hey, I know that DH equals VH times T, and if I'm looking for T, I need to bring the VH over here, and I say, hey, it was 3.8 meters over, and the over speed was 5.92 meters per second. So apparently it took 0.642 seconds to get over to the wall. So this is the time that we were missing there. I can write. So now we should be able to figure out that first part.
Absolutely fantastic.
And when I did that, I found 5.77 up. Because I got a positive displacement there. Is that what you got, Ricky?
That part, yes. And I didn't do the angle.
Alright. So we got that part going for us, which is nice. Now we got to figure out at what angle and speed did it impact.
Yeah, that's
Well, it's going to impact, and I don't know where it's impacting. I don't know, was it still going up when it hit, or is it coming down like I drew it in here? We can't tell just by staring at my funny drawing. We have to actually do some math involved here. So again, I know though that horizontally, the whole time it's going to go 5.92 meters per second. And then I got to find a vertical component. So it's either going to be still going up or coming back down. So how do I find a vertical component? Well, again, all I have to do is say VF equals VI plus AT. So I know my initial velocity vertically was the 12.13. I know my A is negative 9.81, and a minute ago we figured out the time was 0.642. So if I get a positive velocity here, then I'm still going up. If I get a negative velocity here, then I'm headed down. So I end up with a positive 5.83, so that means I'm going up, not down. So my picture's bad because it was still going up when it hit and splattered. So I have 5.92 on the sideways component, and I have 5.83 on this part. This is bad because it's tail to tail. I should draw this over here so I get the angle correct. So if I get 5.92 plus 5.83, I end up with 8.3. And then I say, well, what angle did I impact? And again, my angle here, we have opposite, we have adjacent, so we're still going to use tangent. That's going to look like somewhere in the 40s.
Yeah, that's what I thought.
Yeah, 44.5, looks like 45 degrees upward. So yeah, the black line looks like a much better trajectory drawing than the green line did. That's it.
Oh my
You had
god.
trouble with that, you little wusses?